complex numbers. We know how to find the square root of different numbers. So the square root of 4 is 2, square root of 9 is 3, and so on. But what if we want to find the square root of -1? Well, the ways to do this, what are we actually looking for here? So here we're looking for two numbers, or one number which multiplied with itself will give a negative, -1. But we know that if we multiply two negative numbers, that will give us a positive, and if we multiply two positive numbers, that will also give us a positive. So what can we do? Well, mathematicians have to find a new number, an imaginary number called I, and they have to find I as being the square root of -1. And I, as I said, is imaginary, and to create a complex number, so this is a number which has both imaginary and real parts. And real parts is just the numbers you've always been using: 1, 2, half, quarter, pi, e. So a complex number is in the form a plus bi, where a and b are real constants. So we could have 2 plus 3i. That is a complex number. And we can add and subtract these as we normally would. So let's say 2 plus 3i, and we're going to add that to 7 minus 2i. Oops, not a good bracket. And that will give us 9 plus I. So we've done the 2 plus 7, and then the 3i minus 2i to give 1i. And we can multiply and divide complex numbers as well. So if we have the same two complex numbers, and we multiply them together this time, then we multiply them as if we're multiplying out brackets, as like quadratic. So we've got 7 times 2 is 14. 2 times minus 2i is negative 4i. 3i times 7 is 21i. And 3i minus 2i is minus 6i squared. But what is I squared? This is one thing we haven't covered yet. Well, I squared, if we have a look here, so I is the square root of -1. So that means that I squared is -1. So going back to here, we've got 14 plus 19i plus 6. And that gives us 20 plus 19i. And then for our final example, we are going to look at is a A-level style exam question which comes up in first year maths degrees. So if we have z is equal to -3 minus 4i, and w is going to be 2 plus 4i, then we want to find z times w and z divided by w. Now this is one thing I haven't covered yet, is how to divide. So I'll show you how to do that as we go. So we'll start off with zw. So as we did before, -3 minus 4i multiplied by 2 plus 4i. And that gives us -6 minus 12i minus 8i minus 16i squared, which then translates to 10, there's a 10, minus 20i. So now going on to z divided by w. So first of all, let's write this out. So it's -3 minus 4i over 2 plus 4i. Now we want to put this all in real terms. So there's two ways we can do this. We can either, we want to put it into terms of a complex number, not real terms. We can either use, we can either multiply by the conjugate, top and bottom. So if we do that, we will be multiplying by 1, but multiply by 2 minus 4i, 2 minus 4i. So we've made the imaginary part of the denominator negative, and this should cancel out to give us some nice numbers. So if we do this, that'll give us minus 3 minus 4i, minus 4i and 2 minus 4i, which we can calculate, and 2 plus 4i and 2 minus 4i. So the top gives us negative 6 plus 16 minus 16 minus 8i plus 12i all over 4 minus 8i plus 8i, which cancel, and then minus plus 16. So there we have negative 22 plus 4i all over 20. So that has given us our answer in standard complex form with fractional coefficients of I. However, that doesn't really matter, they're real. The other way you could do it would be to, I'm not going to do it now, but just show you the first step, is to say we're going to take a over 2, add it to b over 4i, multiply or add these two together, and then compare coefficients with this and find out what a and b are, although that way is a bit tedious. So we've had a look at coming up with imaginary numbers, adding them, subtracting complex numbers, but what actually is a complex number? So we can show this on a graph. Apologies for the not so straight lines. So over here we have the real domain, and here we have the imaginary. So if we put some numbers on here, 1, 2, 3, 4, 5, and we pick this point here. So this is 2 plus I. And if we go for this one over here, this is 5 plus 3i. So all we have is the vector. Oops, that should be a straight line. The vector which takes us from the origin to the point. And if we went for this one, oops, it's not very good, but you can see what I'm going for, 1 plus 4i. So you can see here on this graph that we have all of the real numbers in our number line. So going back to primary school, you can have this will be 1, this is 2, this value on this point is 3, and so on. And if we go up this way, pick a different colour, we've got I, 2i, 3i, out point is 4i, and so on. So the real numbers compare directly to the imaginary numbers in that you've got the number line, and then this graph which is called an Argand diagram, is the visual representation of what complex numbers really are. So they are a mix between real and imaginary numbers. Thank you for watching.